All right. Now we are going to talk about how to measure accuracy of a machine learning model. So because the idea is to create a machine learning model that is as accurate as possible. So let's dig into that. So here you see some data. So here there is just one feature. So x is one-dimensional. So we can plot it. So we have several observations. Each observation is plotted as a dot. And we have three models. So the blue, the red, and the green. And we can see that the blue model is, of course, is closer to the actual data. So it is better than red or green. So how do we quantify it? So the idea is that we are going to measure deviation of each of these models from observed data. So deviation means the sum of these squared or just distances. So like for the blue model, so this is a small deviation here, small deviation here, small deviation here. So for every feasible value of x, we measure the distance between the predicted value of y and the actual value of y. And the smaller these distances are, the closer our model is to the truth. So for the red model, it is a bit different. So for the red model, it's going to be this distance plus this distance plus this distance again, and so on and so forth, plus this, plus this. For the green model is even more. So how do we quantify it? So there are two kind of most common methods. So one is called the mean squared error. So recall that the superscript here means that we are taking the sum over all observations in our data. So for each observation, we take the actual value of y, which is yi. So this is the actual value, actual. And f hat of xi is the predicted value. So then we can square it because we don't want it to be negative. So the idea is that this should be some kind of an error. So if the error is 0, it means that our model is perfect. It does not deviate from data. And the more the error is, the more the model deviates from observed data. So the error means deviation from data, so which is why it needs to be positive. So another method is very similar. It's just that we replace squares with absolute values. So mean absolute error. So just for your information, this is a little table of errors. So, and of course, the blue model here is the most precise with respect to both mean squared error and mean absolute error. But the values are, of course, different. So what I want to say is that the measure of how much a model deviates from data or a measure of goodness of it depends on the choice of the error function. And here is a little quiz for you.